Hello everyone. In the previous lecture, we stopped at collection and conveyance of water. Okay. If you observe the flowchart of water supply engineering, it is going to look like this. What is the flowchart? The water supply engineering starts at source source of water, and then it deals with collection of water, and then conveyance of water. Where do we convey? We convey the water to treatment plant, and then after the treatment we distribute the water to the community. Okay. In the previous lectures we studied sources of water, how do we collect them, how do we convey them. Here in the next topic we have to study treatment of water, right? But before going to the treatment of water, first you should know water quality or water quality testing, right? The reason is, if you want to give treatment to the water, first you should know what are the problems with water, what are the problems with raw water. Raw water means the naturally obtained water from the source which hasn't gone any artificial treatment. I hope you understand that sentence, right? If you want to treat the water, first you should know what are the problems that are present in the water. If you want to know the problems in water, first you have to test that water. So you should study water quality testing. The water quality testing will be done at two stages: one before the treatment and two after the treatment. The reason is, for example, assume that you have a ill person with you. If you have a ill person with you, what you do? You will take him to the doctor. So the doctor is going to first test the patient to know what are the problems with him, what are the problems with him. Once he finds out the problems, he will start the treatment. Once again, after the treatment, to ensure that the ill person got cured, he has to again test. He has to test that ill person again, and then if he is able to meet the standards, he will be discharged. Similarly, here also for the water, before the treatment, before the starting of treatment process, he will be tested. I mean, the water will be tested. After finding all the problems with that water, suitable treatment will be given by the environmental engineer or water supply engineer. Once the treatment is done, again that water will be tested to know the removal of extent of impurities. In other words, to know the uh, suitability of water for the drinking purpose. Okay. Once it is meeting the standards, it will be distributed to the community, right? So let us see water quality testing. If you want to know the water quality, first you should know the impurities present in the water, right? Impurities present in the water. Once you understand the different types of impurities that could be present in water, you can start the treatment process very easily. So let us study first the types of impurities. Impurities can be, let me write, impurities are classified into impurities are classified into three categories. Okay, three categories. Impurities are classified into three categories based on size of impurity, based on size of impurity, based on nature of impurity, and finally based on this classification is very important, based on state of matter. Based on state of matter. If you see the further classification of impurities, if you see the further classification of impurities based on size of matter, based on size of matter, again the impurities are classified into three types. They are suspended impurities, second one is colloidal impurities, and the last one is dissolved impurities. Dissolved impurities. This classification is also called as Engineer's classification. Its classification is also called as Engineer's classification. Suppose the size of the impurity that is present in the water is ranges between 10 power minus 1 to 10 power minus 3 mm. 10 power minus 1 mm to 10 power minus 3 mm, they are called as suspended impurities. The size is ranges from 10 power minus 3 to 10 power minus 6, it is colloidal. And if it is between 10 power minus 6 to 10 power minus 8, it is called as dissolved impurity, right? Let's see the second classification based on nature of impurities. Based on nature of impurities. It is classified into two types. They are organic organic impurity and inorganic impurity. Okay. Organic impurities, whether it is human induced or naturally induced in the water, it is very harmful for the consumption. It is not at all good. No organic substance should be present in the drinking water. And inorganic impurities, it could be present either naturally or human induced. If it is naturally present, like some good salts or good minerals, they are good for health, so it can be present in the water. They are not harmful. If the inorganic impurities that are present in the water are human induced, if the impurities are human induced, then such impurities should be removed. They are harmful for the human beings. Okay, right. And the third one is based on state of matter. Generally, you should know one more thing. The treatment will be given, the treatment to the water will be given based on the size of impurities and nature of impurities. But the testing of water will be done based on the state of matter. So this is also important, based on state of matter. Suppose if you want to find what are the impurities present in the water, then you will study state of matter. Based on the state of matter classification, you will identify the different types of impurities present in the water. But if you want to remove that impurities, then you will see, you will remove the impurities based on size of matter or size of impurities and nature of impurities. Okay, let's see the classification first. Based on state of matter, impurities are classified into three types. First one is physical impurities. Next one, obviously, chemical impurities. And the last one is biological impurities. Okay. So since I have told you that the testing of water will be done based on state of matter, so let us first study these impurities. I mean, let's study the classification of impurities based on state of matter. In the next step, we will study the treatment of water. So obviously, we will study impurities based on size of matter and impurities based on nature of impurities. Okay. Since we should study the testing of water, let us see how we identify the physical impurities, chemical impurities, and biological impurities in the water. Okay. What are physical impurities? The meaning of physical impurities is nothing but if you are able to identify the impurities based on the senses like sight, touch, feel, taste, odor, like that. Okay. If you are able to identify the impurities in the water based on senses like sight, touch, feel, taste, and odor, then such kind of impurities are called as physical impurities. What could be the examples? Like temperature, you can feel it. You can feel it at the same time, even by touch also you can find the temperature. So temperature. And color, through sight you can identify. Turbidity also it can be identified by the sight. Taste, odor, like that. These are the physical impurities that could be present in the water. Odor means smell. Odor can also be called as smell. So these are the physical impurities that will be present in the water. How could a temperature is physical impurity? You might get a doubt that how can we call temperature as a impurity? Temperature is not an impurity, but it is going to tell you the presence of impurities or not. It will tell you whether impurities are present in the water or not. How? Let us see. What is the importance of temperature of water? Okay. Let us see each and every impurity or each and every character. All these are not exactly impurities, but they are going to tell you the presence of impurities. Let's see first the temperature. The solubility of gases. The solubility of gases directly proportional to temperature. Indirectly proportional to temperature. Suppose if the temperature of water is very high, then solubility of gas will be very less, because all the gases will be escaped into the atmosphere because of the high temperature. So if you have more temperature, then dissolved oxygen in the water could be very less. So it temperature tells about solubility of gases. And many chemical reactions are directly proportional to temperature, right? Temperature. So if you have more temperature, there will be lot of chemical reactions that could happen inside the water. So chemical reactions directly proportional to water. And one more thing, very important thing, biological growth. Biological presence or biological growth is directly proportional to temperature. If you have more temperature, the biological growth will be more. The microorganisms present in the water will be very high. Okay. And one more thing you should take care of temperature is viscosity. The importance of viscosity is very much needed during the distribution of water. If you have, suppose generally the viscosity is inversely proportional to temperature. When we talk about water, when we talk about water, the viscosity will be high if temperature is less. If you have very less temperature in the water, then it will become very difficult to distribute the water, because the viscosity in the water will be very high. If you want to have good distribution, easy distribution of water, then you have to maintain certain viscosity. It could not be very much higher. For drinking water standards, the temperature should be in the range of 10 degrees to 20 degree centigrade. If it is between 10 degrees and 20 degrees centigrade, the water is suitable for the distribution. These drinking water standards will be given by IS 10500. IS 10500. This gives the drinking water standards. We will see the next character. What is that? Color. In the physical impurities, we are studying different characteristics. Among them, first one is temperature, second one is color, third one is turbidity, fourth one is taste, and fifth one is odor. So let us see the color. What is the importance of color in the water? Water thought to be colorless, right? Water thought to be colorless. Suppose you are distributing some water which has red color. Even though we have tested and confirmed that red color is not going to harm the human beings, still average consumer is not going to take that water, right? Because of some psychological some psychological presumption, water is always thought to be colorless. Okay, so you have to make sure that water doesn't have any color. So to assess the color of water, there is a device. The color of water can be measured using the device called tintometer. Tintometer, using this device you can measure the color on Burgess scale. Burgess scale. It is also called as cobalt scale, and measured in terms of true color units. These 3 points are very important. True color units, also called as TCU. Water is the color of water will be measured by the device known as tintometer, measured on scale, Burgess scale, or also called as cobalt scale, and expressed in terms of true color units, TCU. Okay, how we measure the color, how do you fix these units? Let us see how we fix the true color units. If 1 milligram of platinum, if 1 milligram of platinum added as chloroplatinate ion, chloroplatinate ion in 1 liter, distilled water, in 1 liter distilled water, color produced is called as true color unit. The units are ppm, or everybody knows ppm can be also written as milligrams per liter. So how do you produce one true color unit? If 1 milligram of platinum is added in the form of chloroplatinate ion in 1 liter distilled water, the color produced is termed as one standard true color unit. Okay, this is very important. This is how you you, you measure the color of water. Okay, right. Suppose the water has 2 TCU. The water has 2 TCU. It means the color produced will be equivalent to 2 milligrams of platinum added as chloroplatinate ion in 1 liter distilled water. Okay, and the drinking water standards for the color is 5 to 20 true color units. 5 to 20 true color units. This should be the standards. Why it should be 5? Why can't it start from 0? Since as I already told that water is thought to be colorless. The reason is, if the color of water is less than 5, then this tintometer cannot measure that color. The tintometer cannot measure the color of water if it is less than 5. That's why the drinking standards are 5 to 20 TCU. Okay, next one is, after color we have to study turbidity, right? Turbidity. Turbidity is nothing but resistance to the light. Resistance to light. Suppose, assume that this is your, sorry, assume that this is a water sample placed in glass jar, and when you have impurities, in the water, definitely if you pass a light through this, some part of light will be absorbed by these particles, absorbed by these impurities. So this resistance to light produced by the impurities is called as turbidity. If you have more turbidity, it means the resistance to the light is more. If you have more resistance to the light, it indicates there is lot of impurities present in the water. Okay, so turbidity indirectly tells you the amount of impurities present in the water. Generally, turbidity will be caused by suspended solids, suspended solids or suspended impurities, you can call it either way, suspended solids and colloidal solids, colloidal solids or colloidal impurities. You can get a doubt like, what if there are dissolved solids present in the water or dissolved impurities present in the water? The turbidity is a surface phenomena. The turbidity is surface phenomena. It has nothing to do with the weight of the particle. It has nothing to do with the weight of the particle. At the same time, the particle must have some surface area. Since it is a surface phenomena, the particle must have some surface. Then only it can resist the light. When you don't have any surface area, then obviously the light cannot be resisted by that object, since it doesn't have any surface area. So the size of the dissolved particles is very small. It is almost equal to 10 to the power of minus 6 to 10 to the power of minus 8 mm. So when you have such a small size particle, it is not going to produce any surface area. So because of that reason, only suspended and colloidal solids are going to cause some resistance to the light, or it is going to cause turbidity in the water. Dissolved solids cannot produce turbidity in the water. Okay, and one more thing you can see in the color, is the color is also produced by two things: suspended solids or colloidal, both suspended and colloidal solids, and dissolved solids. The color produced by the suspended solids and colloidal solids is called as apparent color. Apparent color. And the color produced by the dissolved solids is called as true color. Okay, the color produced by the dissolved solids is called as true color. The reason for calling color produced by the suspended solids as apparent color is, if you keep the water for certain time, if there are any suspended remove colloidal solids, uh, don't add it in the apparent color. The color produced by suspended solids is called as apparent color. The color produced by dissolved solids is called as true color. And in case of suspended solids, we are calling it as apparent color. The reason is, if you keep the water for certain time, assume that I have kept the water for 24 hours, then what is going to happen? Whatever the suspended solids that are present in the water, they will be settled or sedimented at the bottom of the beaker or jar due to the gravitational forces, right? When you have gravitational pull, obviously the suspended solids will have more specific gravity than water, so those particles will be settled at the bottom. So whatever the color produced by the suspended solids, it will be eliminated. That's why we call it as apparent color. In case of dissolved solids, since the size of the dissolved solid is very small, obviously they are not going to be influenced by the gravitational forces. So the dissolved solids will be in the dissolved form or suspension form in the water, so it cannot be settled at the bottom of the tank due to the gravitational forces. So whatever the color that is present in the water, it will stay forever. So that's why it is called as true color. Okay, similarly here in turbidity, in case of turbidity, among the three types of solids, both suspended and colloidal solids possess surface area, possess surface area. So when you have surface area, it can cause turbidity. Dissolved solids does not have any surface area because of its small size. So no turbidity. It is not going to cause any turbidity. Okay. Right. This is the basics of turbidity. Now let us see how we will find out the turbidity. How do we measure turbidity? Right. Turbidity can be turbidity can be measured based on different devices which are which are manufactured based on two principles. First one is based on light absorption, and second one is based on light scattering. Light scattering. Okay. Based on these two principles, different types of devices have been manufactured, and using those devices, you are going to measure the turbidity. And if you want to measure the turbidity, first you have to know some units. How do we express? You need to have some units to express the turbidity. Okay. Turbidity is measured on silica scale and expressed in terms of turbidity units. Turbidity is measured on I have to write it here, measured on silica scale and expressed as turbidity units. Turbidity units. This this scale was introduced by Jackson. It was prepared and introduced by Jackson. That's why units are named as Jackson turbidity units. Jackson turbidity units, JTU. This is how you are going to express the turbidity in water. How the Jackson prepared that scale? Let us see. 1 JTU will be produced when 1 milligram of silica 1 milligram of silica in the form of fine powder 1 milligram of silica in the form of fine powder added in 1 liter distilled water 1 liter distilled water. The turbidity produced is termed as 1 JTU, 1 Jackson turbidity unit. Turbidity unit, 1 Jackson turbidity unit. Okay. Now let us see what are the different types of devices available for measuring the turbidity. As I told you, the devices are manufactured based on two principles. First one is based on light absorption. Based on light absorption, we have different devices. First one is Jackson turbidity rod. Jackson turbidity rod. Second one is Jackson turbidity meter. Third one is Haile's Hailey meter. Fourth one is Bailey's meter. Hailey meter, and the last one is Bailey meter. Okay, these are the four devices available to measure the light absorption. Generally, Jackson turbidity rod devices, it is used for field testing. Field testing. If you want to know the turbidity present in a lake, then you can do the field testing using Jackson turbidity rod. Let us see how we measure the turbidity in water using Jackson turbidity rod. Assume that this is a lake. Okay. You will have a Jackson turbidity rod with a graduated scale and a needle like this. Assume that this is a needle and this is a graduated scale. This is a graduated scale and this is a needle. This is needle. This is a scale which tells you what is the turbidity present in the water. Graduated scale. So what you have to do is you have to dip this Jackson turbidity rod in the water until you are not able to see the needle. Assume that let's say up to 2 JTU. up to 2 JTU, you immerse this Jackson turbidity rod in the water, but still you are able to see this needle. Still you are able to see this needle in the water. Then you have to further immerse or further dip this Jackson turbidity rod inside, and assume that at 9 JTU, just assuming at 9 JTU, the needle reaches this position, and you're not able to see this needle, you're not able to see this needle, then the turbidity present in the water is termed as 9 JTU. Okay, you have to dip that rod until you are not able to see that needle. Okay, this is very simple field testing to find out the turbidity present in the water. Next one is Jackson turbidity meter. Jackson turbidity meter can measure the turbidity in water if it is above 25 JTU. Using Jackson turbidity meter, you can measure the turbidity in water if it is only greater than 25 JTU. If it is not, if it is less than 25, it is not enough sensitive to find out that turbidity. And Hiley's meter. Hiley meter is it can only measure the turbidity in water if the turbidity is ranges from 10 to 50 JTU. Okay, it can measure the turbidity in water if it is between 10 to 50 JTU. And Bailey meter, it can measure the turbidity if it is the turbidity of water is very small. If the turbidity of water is very small, then Bailey's JTU is good for measuring it. Okay, right. These are the 4 devices that are available based on which are manufactured based on light absorption. Okay. Now let us see devices which work on the principle of light scatter. This is very important. Light scatter, based on light scatter. All the previous devices are outdated. I mean, nowadays people are not using them. People are only using the devices which are manufactured based on light scatter principle. So in this, you have only one device. It is called as nephelometer. Nephelometer, it works on the principle of light scatter, and the turbidity measured using this nephelometer will be expressed in terms of NTU. NTU. The units for turbidity measured based on nephelometer are called as NTU, and the meaning of one standard NTU is if we add 1 milligram of pharmazine. If we add 1 milligram of pharmazine in 1 liter distilled water, the turbidity produced is called as 1 NTU. Some people call it as FTU, but this is wrong way of expressing it. The 1 NTU means 1 milligram of pharmazine added in 1 liter distilled water. The turbidity produced is called as 1 NTU. Okay, let's see how the device works. How does nephelometer works? Assume that this is a light source and you will have a lens here. You will have a light here. You will have a lens here, and the purpose of this lens is to focus the all light on one water sample, and perpendicular to this water sample you will have photometers. You will have 2 photometers like this which are perpendicular to the water sample, and you will have a black background. So what you are going to do is turbidity will be measured based on measuring the amount of light that is scattered in 90 degrees from the water sample. the light that is passing through the lens, it will be completely focusing on the, will be focused on the water sample wherever there is a transparency. I mean, the water will contain impurities and water. So when the light is not, when the light is passing purely through the water, it will be reaching the black background. So obviously all the light will be absorbed here. No light will be reflected back. Similarly, if there is impurities present in the water, these impurities are going to reflect the, these impurities will be reflecting the light, right? Obviously they will reflect the light. If not 100%, definitely part of that light will be scattered. So whatever the light that is scattered in 90 degrees will be absorbed by these photometers. These photometers are going to measure the amount of light that is scattered from the light. So based on the amount of light scattered in 90 degrees, you will find the turbidity in the water. Okay, this is very sophisticated equipment. Using this, you can measure the turbidity present in the water. Very important. Even in the laboratories, you might have seen the nephelometers to measure the turbidity. Let us come to drinking water standards. Drinking water standards. If you want to supply the water to the community, the turbidity in the water should be 5 to 10 JTU. It cannot be more than 10 JTU. Okay, right. This is about turbidity of water. This is about turbidity of water. The third topic is order, and the fourth one is, sorry, the we studied about temperature, we studied about color, and then turbidity, and we have to study order and taste. We study both order and taste together. I will tell you the reason. Okay, in Bailey, I haven't told you what is the range between which we measure the light, we measure the turbidity using Bailey's meter. It can measure the turbidity if it is ranging between 0 to 5 GTU. It measures very small turbidity in the water. This is very sensitive equipment. Using Bailey meter, you can measure the small turbidity. Okay. These are important. Drinking water standards are very important. You have to remember all these drinking water standards. It will be available in AS 10500. Right? Now let us come to order and taste. Order and taste. The reason we are studying both together is, when you have taste to the water, obviously it is going to possess some odor or smell. Similarly, when you have some smell to the water, definitely it must have some taste to the water. That's why we are studying them together. We are also going to measure the odor and taste together. If you are able to measure the odor, definitely the taste is also equivalent. I mean, if the order of water is 3, I will tell you what is the 3, then obviously the taste of water will also be 3, most of the cases. Okay, right. The order the order in the water is generally measured using the device called as osmoscope. Order in water is measured using the device called as osmoscope. Okay, how do we find this order in water? That I will tell you. Before that, you have to know the term TON, threshold order number. Threshold order number. Using this number you are going to express the order present in water. This is, you're going to have a small device or small jar having capacity of 200 ml. The capacity of this jar is 200 ml. What you are going to do is you are going to take one water sample. Assume I have taken 20 ml of water sample and I am adding that 20 ml into this jar, and the remaining portion will be filled with or diluted with the distilled water. So this jar has total 200 ml of water, among that 20 ml of sample and 180 ml of distilled water. Okay, and if you are not able to identify the smell of this water, and there will be some experts who are going to smell that water, trained experts. And if you are not able to identify the odor of that water, then what you have to do is you have to increase the sample size, and you have to reduce the distilled water, and you have to do this iteration process until you are able to find the order in that water. Okay, assume that at 50 ml sample at 50 ml sample, I was able to the trained expert is able to find the smell of water. Then the threshold order number, TON number, is given by sample water volume plus distilled water volume whole divided by sample water volume Okay, this is how you are going to find the threshold order number. If it is less than 3, then it is good enough to supply to the community. If it is greater than 3, then it is not good enough. For example, here let's see, 50 plus 150 divided by 50. The TON number you are going to get, threshold order number, is 200 divided by 50, so 5 fourths. TON value is greater than 3, so such water cannot be supplied to the community. The reason is that smell can be identified by the average consumer. If TON number is 1, then only trained expert can identify the odor or smell. Okay, if it is equal to 2, then average consumer can identify only if said. I mean, if you say that this water is having some odor, and you are giving that water to the average consumer, then only he can identify that smell. If TON is equal to 2, suppose if TON is 3, then you don't need to tell the consumer. Directly he can smell that odor from the water. Directly average consumer can identify that odor. Okay, that's why the TON number should be always less than 3 for drinking water standards. TON should be always less than 3. The reason I told you, if it is 3, the average consumer is going to directly identify the smell of water. If it is less than 3, I mean if it is equal to 2, then there is no problem, because the consumer cannot identify on his own. Only if you said that it has some smell, then only he can identify. So that's why the smell or the TON should be always less than 3 for the supplying of water. And the taste of water is also similarly identified by this method. The taste is expressed in terms of FTN, flavored threshold number, flavor threshold number. The formula is same. The sample size plus amount of distilled water added divided by sample size. The A plus B is always constant. It is 200 because the capacity of the jar is 200 ml divided by sample size. What is the amount of water you have taken, right? The FTN value you are getting, that is going to express the taste present in the water. Okay. FTN for even for taste also, for drinking water standards, it should be less than 3. FTN, TON, all these things, all these two things, these two things should be less than 3 for supplying water. Okay, these are the physical characteristics of water. As I told you, the classification is based on state of matter. Based on state of matter, we classified them into 3 types based on physical characteristics of physical impurities, chemical and biological. We studied physical characteristics, and in the next class we are going to study chemical characteristics or chemical impurities present in the water. I hope you understand this lecture. Thank you.